Hi, welcome to my tutorial. My name's Gaia and today I'll be demonstrating and explaining how to factor trinomials. So I'll be explaining this for the approximate age of 13 onwards, so for grade level 9. Let's start. So, first off, what is a trinomial? A trinomial is a polynomial, which is an expression consisting of more than two algebraic terms with three terms. You can remember this because tri from trinomial means three, deriving from Latin. There are three different types of trinomials, as you can see from this table. In this video, I'll be focusing on type 1 and type 2, as they are both solvable using the same mathematical procedure. These are also called quadratic trinomials. Type 3 is a little different and a little more complicated. The degree of a quadratic trinomial must be 2. In other words, there must be an exponent of 2, and that exponent must be the greatest exponent. Examples of correct quadratic trinomials are shown below. The first one, for example, 3x squared plus 2x plus 1, is correct as it has an exponent of 2, and it is the greatest exponent as none of the other terms have any. It also has three different terms. The other two examples are also correct as they follow the same structure. On the other hand, some examples of incorrect quadratic trinomials are shown in this table below. The first one, 3x to the power of 3 or 3x cubed plus 2x plus 1, is incorrect as there is an exponent greater than 2. The second one is incorrect as it has no exponent of 2 and it only has two terms. And the last one is incorrect for the same reason as the first. Today I'll show you the easiest step-by-step method to factor trinomials, which is most generally called the Xbox method. It is very straightforward. The main idea behind this method is to obtain two numbers that multiply to equal the product A times C, or AC, and add to equal B. So, multiply for AC, or A times C, and add for B. Let's get started. Okay, so now I'll give you a problem, and then I'll walk you through the mathematical procedure of the Xbox method to obtain the answer. So, example, factor 2x squared plus 7x plus 3. To use the Xbox method, we must first identify what A, B, and C are. So, in our equation, A will equal to 2, B will equal to 7, and C will equal to 3. Therefore, AC, which is A times C, will be 2, which is A, times C, which is 3, will equal AC, which is 6. When identifying A, B, and C, we just go from the top of our equation to the bottom in order. Also, we don't need to include any variables, such as x or exponents. Our second step, when utilizing our x graphic, we need to find the two numbers that will multiply to AC and add to our middle term B, which in this case, in our equation, is 7, or 7x, but you don't need to include the variable. This is our x graphic right here. So we need to find two numbers that will multiply to 6 and add to 7. You can use trial and error with factors to find the two numbers you're looking for and test out all your options. So let's use the table I made below. We're trying to find two numbers that will multiply to 6, so we need to find its multiples of 6, and that will add to 7. As we can see here already, the multiples of 6 are 1 times 6, 2 times 3, and then we know these are all its multiples and factors, as then 3 times 2 is the same thing and it joins up. So we are done here. And we have already found the two numbers we need, as 1 times 6 is 6 and 1 plus 6 is 7. Now that we have found the two numbers we need, so two numbers that multiply to 6 and add to 7. 6 times 1 is 6 and 6 plus 1 is 7. Our next step is to rewrite our initial equation, splitting the middle term, in our case 7x, into the two numbers we just found, the two multiples we just found. So it will then become 2x squared plus 6x plus 1x, or just x as it's the same thing, plus 3. After this, we have to factor by grouping. This means splitting the equation into two separate brackets, as you can see I have done here. So we will split it perfectly in half. Our next step, step 5, is to find the GCF, which stands for greatest common factor, for each of the brackets, for both two brackets or two groups, and factor them out. Now, before I continue with our equation, I'll show you how to find the greatest common factor from simple numbers, and this will help you later on, especially if you don't already know how to find a greatest common factor or what it is. Let's take 6, 2, and 12 as our example. So we need to find the greatest common factor between these three numbers. First, we need to find all of their multiples. So, as we saw before, the multiples of 6 are 1 times 6 and 2 times 3, as then it will go 3 times 2, and it joins up, so we know we are done. The only multiples of 2, since it's a prime number, are 1 and 2, as then it will proceed 2 times 1, and it joins up as well, so we're done here. And the multiples of 12 are 1 times 12, 2 times 6, and 3 times 4. And we're done here as well. Now, to find the greatest common factor, basically means we have to find the multiple that has the highest value, so the highest number between all three. Now, if we look, 6 and 12 have a common multiple of 6, which is the highest between the two. But since 2 doesn't have it, we have to keep moving down. 3 as well, but 2 doesn't have it. So keep moving down to 2. And now we find that all three numbers have a common multiple of 2, or a common factor of 2, which is the highest between all three. So we have found our greatest common factor. Now that you know how to find the greatest common factor from simple numbers, we can do this for our equation as well. So let's go back to step 5. Find the greatest common factors for each of the brackets. These are our two brackets. So for the first bracket, we will find that the greatest common factor between 2 and 6 is 2. But since both terms have at least one x, since x squared is made up of x times x, and x is 1 times x, our greatest common factor turns into 2x. Now, the greatest common factor for our second bracket between 1 and 3 will be 1, and since only one term has an x, it remains as 1. Step 6. Use the greatest common factors to factorize the brackets. So after we have done this, our equation will look like this. These are our two greatest common factors. And if we multiply this out again, 2x times x will be 2x squared, 2x times 3 will be 6x, 1 times x is x, and 1 times 3 is 3, which will lead us back to the two brackets we had before. After step 6, we will be left with the two common factors here, 2x and 1, and the common quantity of x plus 3. So we can simplify this and write this in factored form. All we have to do is join the two common factors into one bracket, and then the common quantity of x plus 3 in another, and we are done. We have factored our trinomial. Now, if you want to check your answer, all we have to do is expand it or multiply it out again using the FOIL method. FOIL is an acronym for first, outside, inside, and last, as you can see from this picture. Basically, for our equation, we have to do 2x times x first. Then we do plus 2x times 3 plus 1 times x plus 1 times 3. Now, after we've written this all out, we will see that 2x times x is 2x squared. 2x times 3 is 6x. 1 times x is x. And 1 times 3 is 3. Now, we have our equation, but we need to combine the like terms. As you can see here, they have a common variable of x. So our equation, once we have combined them, will turn into 2x squared plus 7x plus 3, which is our original equation. So we know we have done it correct. That's how you check it. Let's try another example. This is a guided practice section. So I'll prompt you with a question you need to ask yourself, give you a few seconds to think about it. You can pause the video if you want and answer it for yourself. And thereafter, I will give you the correct answer and explain to you how I got to it. My first question to you is, what are we trying to do here? You may pause the video if you'd like. We are trying to factor this trinomial, x squared plus 15x plus 56. What is our first step? How do we do that? We have to identify the values. In our equation, a will be equal to 1 as x is equal to 1, b 15, c 56, and therefore a times c will be 1 times 56, so ac will be 56. Now what? We have to find the two numbers that multiply to 56 and add to 15 by testing out the multiples of 56. We will find that these two numbers are 7 and 8, as 7 times 8 is 56, and 7 plus 8 is 15. What is our next step? Now we have to split our middle term into the two numbers or multiples we just found. So 15x will be split into 7x plus 8x. Our equation will now be x squared plus 7x plus 8x plus 56. What is step 3? For step 3, we have to factor by grouping, so split the equation into two separate brackets. Then our equation will turn into this. What is our next step? We have to find the greatest common factor for each of the brackets. What are the greatest common factors? For the first bracket, the greatest common factor will be x, as they only have an x variable in common. And for the second one, since 8 is a factor of 56, it'll be 8. Now what? Now we have to use the greatest common factors to factorize the brackets. After this, our equation will look like this. Now, if we expand this out, it'll be x times x is x squared, x times 7 is 7x, 8 times x is 8x, and 8 times 7 is 56, which will bring us back to the two brackets we had before. Now the last step to get our answer, we have to write our equation into factored form. After step 5, we were left with just the common factors and the common quantity of x plus 7. So we can simplify this as factored form, which will then become x plus 8 and x plus 7. Now we are done. If we want to check this, what method do we use? And how do we do it? To check our answer, we use the FOIL strategy to expand. You can follow my diagram as I go. X times x will be x squared, plus x times 7 will be 7x, plus 8 times x is 8x, and 8 times 7 is 56. Now what do we have to do? Now we have to combine like terms, as 7x and 8x both have an x variable in common. We have to combine them. After we combine them, we will have x squared plus 15x plus 56, which is our initial statement. So we know that we have solved this correctly, and we are done. In conclusion, to end this video, my MLA Works Cited list. Thank you so much for listening. I hope this tutorial was useful, and if you want some more examples on how to solve negative trinomials, you can just follow up on my next video. That'll be all. Bye! Till next time!